And I stick to what I said before I started making the video. Those of you who keep up with the homework will find this the easiest chapter. You'll be dying for me to have a test for this. You'll be like, please have a test for this. We got a timing problem on the test. We'll talk about it as the week goes on. Fairly straightforward. Some new symbols, some new terminology. But if you do your homework, you're going to be fine. New word, sequence. Well, you've heard the word sequence before. But in math, a sequence is an ordered list of numbers. Here's an example right off the hop. Here's a sequence. 2, 5, 8, 11, 14. Individual numbers like that. Notice this sequence ends with a dot, dot, dot. I didn't know how else to type that up, so I just wrote a little dot, 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 but I'll just highlight it there and there. It ends with a little dot, dot, dot. And the implication there is that this sequence just keeps going on forever. This particular sequence is called an infinite sequence. It goes 2, 5, 8, 11, 14. Stops there because it's like, you got the gist of it? You see what's happening? And you're like, yeah, I got it. All right. But meanwhile, the sequence actually goes on. 17, 20, 23, 26, 29. It goes on forever. Don't worry about that. That's not going to bother us too much. But we could have had the same sequence and end at a certain value. So I could have done the exact same sequence. Look here. 2, 5, 8, 11, 14, 17, 20, 23. Stop. You can stop a sequence and say that's as many as we're going to do. So in this case, the sequence has 8 terms. Now this is, I just typed this over the Christmas break, so as I'm doing it, I'm checking for errors, yeah, in case I made a little error in my typing. Was it 8 terms? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it is 8 terms. And let me just label them and show you how we're going to label them. And I think you'll like this once you get used to it. This first one will be called term 1. Fighting with this already. No? All right. Just 1 second. Oh, I'm going to move that down so you can see a little bit better too. So move that down. Switch to pen. Oh, now we're all good. So this first one will be called T1. And what that means is term 1. Nothing too strange about that. T1. That's new, but not that weird. Term 1. And so this next one here will be called term 2, term 3, term 4. That's how we'll label them. That's a little different labeling than we've done in the past. So the first sequence was an infinite sequence with an infinite number of terms. And don't let the infinite word scare you here. We're not going to get all crazy on that. It just means it just keeps going if you wanted to. Each term in the sequence has a term number, and I've already given away what I'm saying here. I wrote it up there. I thought that was better for your note, actually, but here it is typed up. Each term in the sequence has a term number. We will number the terms in a nice, simple manner. The first term will be called term 1, and we'll use a little T1 to indicate that it's term 1. The second term in the sequence will be called term 2, and we'll use a little T2 there. If you're bored, good. I'm nothing complicated here about the situation. And then the third term will be called term 3, and we'll use T3. And the fourth term will be called, ooh, there's the error. The fourth term will be called term 4. Can you fix that in your note? I didn't know there was an error, but I assumed there was. And then that'll be called T4, and so on. That's how we number the terms. Are we okay so far? I don't think you have to do much copying down here, because I don't think there's a lot to worry about in copy here. But you just tell me if I go through the slides too fast. So, our first special type of sequence. And when it says our first, you're going to be like, oh, here we go. There's going to be all these special types of sequences. No. I only have 2 types of sequences, or special types of sequences to show you. The first one's called an arithmetic sequence. Do you need to be able to say arithmetic? No, but that's what it's technically called, an arithmetic sequence. Don't assume something difficult's coming. An arithmetic sequence is just like the one I just saw. Arithmetic sequences are very nice and friendly. Okay, I'm going to try and do this the way I wanted to last time. I'm going to use my finger as a highlighter. There we go, and yellow, good. Arithmetic sequences are very nice and friendly. Isn't that finger supposed to be highlighted? No? Okay. Arithmetic sequences are very nice and friendly. They are. They're the nicest sequence going. In an arithmetic sequence, the sequence goes up or down by the same amount each time. That should sound sort of familiar. We've done situations like this before where we go up by the same amount every time. It should remind you of linear functions. Linear functions did that. The amount the sequence changes from term to term is called the common difference. So there's a word. And this is what I'm talking about. Like, if you don't do your homework, when the word common difference appears in the test or the exam, you're like, what's the common difference? See, that's one of the things we're trying to do, is get used to the word. If you use the word common difference in your homework a bunch of times, then when it says common difference, you know exactly what we're talking about. So the sequence from example 2 is arithmetic, the sequence I was just doing. It goes up by the same amount, 2, 5, 8, 11, 14, 17, 20, 23. Its first term is 2, and its common difference is 3. Maybe you can just look at that and find the common difference. But if the numbers get complicated, let me show you how you actually handle it if you wanted to do the common difference. Still having trouble with that. If you want to find the common difference, and the numbers are complicated, because I hope most people look at 2, 5, 8, 11, 14, and they know what the common difference is. But if you needed to find that common difference, you might go over here and do a little calculation. You'd go D equals 5 minus 2. And yes, I'm giving away something else. We'll call that common difference D for common difference. And you just take one of the terms and subtract the term before it, and you'll find the common difference. You might think that's overkill, but that's because the numbers here are easy. I'm going to jump ahead in the lesson a little bit. We'll call this thing A, the first term. And it's because it's the letter A. First term, first letter. Okay, so I'm jumping ahead a little bit in those things. It's in the lesson later, but I wanted to mention those things. Okay, so far what have I said? Arithmetic sequences will be a list of numbers. The first term we'll use the letter A, and whatever it's going up by each time will be called the common difference. You can find it by subtracting. That's it. That's it so far. Do you have any questions about that? You don't have to write much, right? You're just adding little doodahs to this, okay? A little bit of writing coming. Example 4. Is the sequence 23, 18, 13, 8, 3, negative 2, negative 7 arithmetic? And the answer is yes. We can see the sequence goes down by value 5 with each term. So let me write that on there. If you're having any trouble with the idea here, this goes down 5. Then it goes down 5. And it goes down 5. Down 5. And it keeps doing that each time. And when it does that, we call it arithmetic. This time it happens to be going down by 5. So the common difference is negative 5. That's working now with my highlight with the finger. All right. How would you get that common difference? If the numbers get complicated, you just take one of the terms and you subtract the previous term. And that's why it's negative 5, because it's going down. That's if the numbers get complicated. If the numbers are simple, you might be able to just look at it, and that's fine. But if you had to calculate it, you'd subtract. Is the sequence 5, 15, 45, 135, 405, 1215 arithmetic? Does it go up by the same amount each time? Let's check. Oh, hang on. Say your answer in just a second. He's establishing one of the most important things of the chapter. Not difficult, but one of the most important things. Here, if it is arithmetic, it should go up by 10 every time. Does it go up by 10 every time? No, this one goes up by 30. Oops, I said 30. So this is not arithmetic. But Nathan said something here that's going to be important. He's already tripped on our other sequence we're going to do on a different day. What does happen every time, though? It multiplies by 3. That's different. We'll call it, you don't need to know this word yet. We'll call that a geometric sequence, and we'll do that on a separate lesson. So the other sequence we'll do is it multiplying by something every time? Those are the only two possibilities in the whole chapter. 17 different possibilities coming up here. We'll either look at arithmetic ones that add or subtract something, or we'll look at geometrics that multiply or divide by something.
If it multiplies or divides, is it still a common difference?
No, it'll be called the common ratio. Okay? And that's getting ahead of ourselves. All that stuff is getting ahead of ourselves. I'm glad it happened so we can see what's going to happen in this chapter. First, arithmetic. So for tonight's homework, when it's not arithmetic, when it doesn't go up by the same amount every time, we just go, oh, that's not arithmetic, and we stop. Later in the chapter, we'll deal with those type of sequences. Questions there? We're cruising right along. It might have looked big when you got the lesson, right? 4 pages, but I think we're going to zip right through this. Yes, sir.
Isn't it like, it's kind of like linear and like...
It's exactly like linear. The only difference is you can't have half terms here. When we were doing linear functions, we had a straight line. We could sub in 2.1. We could sub in 3.7. We could have decimals. Here, no decimals. Yeah, whole values. Term 1 or term 2. Yeah? Good point. So, is there a formula for this situation? The answer is a big yes. And I'll explain the formula in a second. I'll explain where it comes from. But it's a very handy formula to use. A formula for arithmetic sequences. When doing work with arithmetic sequences, the following formula will be found to be very useful. This is a handy formula. And I'm going to do some examples to show you how to use it. Tn equals a plus n minus 1d. Tn is whatever term number you want. So if you want the 80th term, you can use this formula to get it. A is the initial number of the sequence, whatever you start with, and n is the term number, and d is the common difference. I'm going to take this thing for a test drive. So if you're like, I don't know where you're getting this formula for, by the time the lesson's over, you're like, oh, I see why this is the formula. I decided in this lesson to not develop the formula, give you the formula, and then show you why it works. Okay? So this is your reference that you go back to. You can put a big star on that to go, this is what I look back on when I need the formula for the situation. It's the only formula for the evening. There's one other formula I got to show you for geometric ones, but this is the only formula you'll need to do any work tonight. Let's go back to example and make the formula. So I'll go back and say, let's see where this formula comes from. So, what's the first term in the formula? Yes. In this particular case, the number 2. I was looking for the value. What's the d here? 3. It's going up by 3 every time. Now I'm going to do something at first. As I'm building this table, you're going to be like, what are you doing? And by the time I'm done building this table, I'll be able to perfectly explain this formula. Okay? That's my goal. So just play along with what I'm doing, even though it might seem a little weird how I approach this. So, term number 1. The first term is 2. It's called term 1. It's also called A. You can call it A or you can call it term 1. Now, term 2, I know, it's on the list there. It's 5. But I'm going to make some other calculations to show where it comes from. To get the second term, I take 2, which is the first term, and I add the common difference. And that's how I get my number 5. That's where the arithmetic sequence comes from. You take the first term, 2, and you add 3 onto it. You're bored. You should be bored. It's not exciting what I'm doing there. Here's what's exciting. When I go to find the third term is take the 2 and add 3, but then add 3 again. Hopefully you're thinking, I wouldn't do that. I'd take the 5 and add 3. I'm like, I know. I'm trying to build the formula. I got to think differently to build the formula. So really what I'm doing here is I'm taking 2 and adding 2 of the 3's. That's what that term really does when you get down to it. If you're 47% confused, that's okay. I'm going to just keep doing it till it's going, okay, I see what you're doing here. Term 4. To get term 4, I take 2, and I add 3, then I add 3, then I add 3 again. What I'm really doing is I'm taking 2 and adding 3 of the 3's. I'm almost home to explain the formula. Because down here, I'm going to challenge someone to come up with term 99. That's all I want out of this, is that you see the pattern and go, oh, I can get term 99 easily without going through the table all the way down. Listen carefully. For the fifth term, I take the number 2 and I add 3 only 4 times. I add 3 once to get to the second term, then again to get to the third term, then again to get to the fourth term, then again to get to the fifth term. Really what I'm doing is I'm going 2 plus 4 of the 3's. Well, let's see if it works. What is 4 times 3?
12.
And then add 2? 14. See, it works. I can get to any term like that. Now, someone clever to show me how to get term 99, and then back to the formula to make you go, oh, I see where that formula comes from. Here's my hint before I ask someone. To get the fifth term, I took 2 and I added 4 of the 3's. To get term 4, I took 2 and added 3 of the 3's. To get term 99, who wants a shot at it? Ben.
2 plus 98.
98. That's right. You're right. I'm going to act like you're not right, okay? Isn't it term 99? Why are you only adding 98? It's always 1 less. Back to the formula. Term 1, n minus 1. 1 less than the n is how many times you're going to multiply by d. That's why that formula is like it is. Nothing too complicated. I know the new symbols make it look like it's really complicated. It's just this. It's just what he said. Then add 98 of the 3's. See, now I can jump to any term you want. You want term 1,000? Just a second. I can get it. You want term 5,000? No problem. I've got a formula now to get to any term. Can I do this in my head? Who's got the calculator ready to check if I'm getting old? 296. That's what the formula does. Jumps to any term you want. You don't need to use the table to go up to individual terms anymore. Okay? 1 less. That's why the n minus 1. The n minus 1's awkward, I know. But it's 1 less than the term number. To get to the 99th term, you only add the common difference on 98 times. Yeah? Questions? That's page 2 of 4 already, is it? Yeah, see, we're cruising right along here. Do you need more time there? All right. But that's not the real power of this formula. Well, it is. I sort of showed that off. Here's the power of the formula. Use the formula to find the 45th term of the sequence. Okay, here's the actual steps. When you do your homework, this is what you'll do in the actual steps. So what color am I going to do this in? I got to do a fancy color here. Geez, Christmas is over. No more festive green or red, eh? What's the next holiday? Well, my birthday's first, so you don't care about that. Valentine's. Oh, we are back to red again. Okay, I guess we're using red. Valentine's red is what we're calling it from now on. Oh, it activated. Good. Here's what you do. Here's how you do your homework questions. Okay? This is switching over to homework mode. I designed this lesson carefully that these ones, you got to do a lot of writing. You first write down the formula. Tn equals a plus n minus 1 d. Mr. Todd, do I have to memorize the formula? The answer is yes, but if you just do your homework, you'll automatically have it memorized. You'll write it down so many times, you'll be like, I remember what it is. So the formula here, Tn equals, to get any term you want, you can jump to the 99th term, the 561st term, doesn't matter. You go a plus n minus 1d. What's the a in the formula from above? 2. That's all. Nothing crazy. A is that first term. We call it A so people know the first term. First letter, first term. What's the D? 3. And that is the formula. Is it beautiful looking? No, we can probably do better. You don't have to do better. You could use it like it is. But let me show you how to make it a little nicer. First, I'm going to put the 3 out front. This formula puts the 3 afterwards. And we could put it out front instead and say, OK, well, the 3 is going to go here. Then I'm going to distribute those brackets. I hope this isn't blowing your mind on the first day back from Christmas. I'm just distributing the 3, and then I'll collect up some like terms and get what I think is a beautiful version of this formula, much easier to look at and use. You want to get any term? Go 3 times the term number and subtract 1. That's nice and easy. You can test it out if you want. This one asked for term 45. So to get term 45, I just go 3 times 45 and subtract 1, which I think is 134. Someone got their calculator ready just to make sure Mr. Todd isn't losing it?
Wait, where did the 2 go, though, Mr. Todd?
Which 2?
There's a 2 somewhere.
Here? This 2?
Yeah.
It combined with that negative 3.
Why did they turn from -3 to negative 1, 3?
Because those are like terms.
Oh, true.
So true. So true. How'd I do? Someone punched in their calculator? See if Mr. Todd's losing it? You're doing good with the phones. The headphones we're going to have to work on, though. What am I going to do with headphones? I need a weapon. I will smack people with my ruler wearing it. No. Of course I will not smack people with a ruler. That's not on the video. I'll just Zorro those headphones right out of your ear. I'll reach in with this and whoosh. What's the little thing? What's the little thing on the bottom called? Of your headphone? Little,
Wires?
no, it's like they got a name for it. The nub, the tab, the. I'll remember it in a second. Do you have any questions about example 7? 8. The number 353 is in the sequence. Find the term number. Huh? Write down the formula that I've got here. Beautiful formula. 3n minus 1. And let me just say out loud what this formula does, and hopefully you go, oh, this isn't so bad. If you've got the term number, you put it in as n, and you'll get the value of the term. This doesn't give me that. It gives me the value of the term. It gives me 353. Where do I put the 353?
Can't you just like invert it though, the whole thing, like divide by 3 and then plus 1?
Absolutely. That's exactly what I'm going to do.
Right on.
Most people, you can do exactly what he said, but most people will just go sub 353 in as Tn. They'll say, I need this formula to produce 353 as the answer, like always in math. We give you a formula, we get you to use it one way, and then we get you to use it backwards. And then we do what he said, which is do the inverse operations. 353 plus 1 equals 3n. 354 equals 3n. Then divide by the 3. And I get 118. Therefore, it is term number 118. Okay? So this formula can be used forwards and backwards if you need to. Do you have questions? Now, as I was typing this up on December the 27th, I think is when I got back to work and started getting ready to come back here. As I was typing this up, I was like, maybe, just maybe, there's some people in class who have a New Year's resolution to do better at school in general. So I typed this up in a very specific way that you might do in lessons like this, is to go, what have I learned so far in this lesson? And make some little notes off to the side, some little arrows. You don't have to do it this time. I did it for you. But this is the way to get better. Not work harder. It's not more work. It's just study better. So I made a little note, what we've learned so far. A little summary of what's happened. Study/homework notes. Example 6 showed us how to take a given sequence and make a formula. See, now when you're doing your homework, you're like, oh, question 3, they gave me a sequence and I have to make the formula. Now you know where to find that example. You can still text or email me, but I'll be a little disappointed Not in you, in my notes. See how good these notes are? Example 6 does this. Example 6 also showed us how to take the formula and produce the first few terms in the sequence. Example 7 showed us how to use the formula to find any term in a sequence. And example 8 showed us how to use the formula and a certain term to find the term number. So when you get to your homework, it's like, oh, how do I find the term number? Look at example 8 shows you how to do that. I'm not trying to get out of answering your emails. I'm trying to help you become more independent on these things. I'll still answer. Yeah, especially tonight. Tonight's easy. It's game night at the Todd house. I'll just be sitting there waiting for people to roll the dice and take their turn so I can answer your little emails. Okay? If you've got a New Year's resolution of doing more homework. Questions there? All right. How many more examples do I got to do?
One.
Just one. It must be a doozy if I've left it to the end, eh? Here comes the example of the day. In an arithmetic sequence, term 7 equals 121, term 15 equals 193. Find A and D. So if the toughest question so far was a difficulty 50 out of 100, this is 108. This is a giant jump ahead. Let me show you how to do it. I'm going to go over here and I'm going to write the formula. Tn equals A plus n minus 1 D. And I'm going to say, but term 7 equals 121. Maybe this is you doing your homework on this question. You're like, well, I don't know what to do, but I know term 7 equals 121. That means, and please pay close attention right now. If you're only going to pay attention for 90 seconds, this is the 90 seconds. Watch how I think this through. That means if the n is 7, do you see me plug in the 7 there? If the n is 7, then the term is 121. So I subbed in the information I had there, and I get this, which is really scary. Really, really scary what I'm going to write here. 121 equals A plus 6D. Anyone want to put into words why that is completely scary?
No, it's not.
What's the problem with this equation? Yeah, sorry. You're right. 7 minus 1 is 6. That's not scary. What's scary now about the situation? 121 equals A plus 6D. Two variables, one equation. Can't be done. Can't be done. No one is smart enough, no one, to solve an equation that has two unknowns in it. But I'll give you, hopefully, this might even elicit a groan. Somebody, when I write, I'm just going to write something here, and people might go, I see what's about to happen. Maybe. If not, I'm going to teach it. That's my first equation. Did that trigger a memory for anybody? Maybe? A couple people, Another equation. Tn equals A plus n minus 1D. But term 15 equals 193. Who wants to try and do the subbing for me? Kyle.
Isn't it just you put the 193 out front, like equal
Yep.
A, and then you do 193 minus 1 again? No. You just do 190. Wait, what's I'm not understanding this now.
No, just take a second. Take a second, look at this one.
190.
What did I put there?
What? That's 7. Oh, 15.
Good.
15. Actually, I thought like the big number.
And those of you who want to start getting better at these type of things, this is what you got to do with the notes, is look back. Some of you, I think, are taking the notes and go, okay, notes are over, put those away, now do my homework. No. Notes top of the desk, homework right underneath. Yeah, I'm making an effort here. I'm going to sound like your mom or your dad here for a second, but I made these notes for you. They're not for me. I can do all this stuff. This is for you, your guide to do your homework. And I get 193 equals a plus 14d. What's really scary about this? What's the problem here? Two variables. No panic, though. I'm going to write them over top of each other. And hopefully, and write the first equation, 193 equals a plus 14d. That was technically equation 2. 121 equals a plus 6d. And now we'll see. Does anyone, do you remember? Eliminate. The little 1 and 2 did trigger his memory. And in this case, on this day, actually the elimination is nice because look at the A's are already matched up. I don't have to do any crazy elimination steps. Sometimes maybe we will have to, but in this one it's nice. The A's are already lined up. You can just subtract right now. 72. A minus A, eliminated. That's why it's called elimination. By subtracting the equations, we eliminated that, and I get 8d, and right at that moment, the fear alleviates. Happiness returns to the kingdom. You order a pizza because you're like, I got it, I got it. 72 divided by 8 equals d. 9 equals d. Yes. And then you get it back on the test, and you got 3 out of 4. You're like, 3 out of 4? I did it. D equals 9. What did the question ask?
Find A as well.
Find A as well. So I've trained the calculus people. As they walk up to hand tests in, they're reading their test as they go. Did I answer the questions? It's easy to get caught up in algebra and get distracted by how smart you are and forget to answer the question. Well, who's got this? Who knows what to do now with the D as I play with my active board? Kyle says it's so easy. What do we do?
So I think you just do 9. No. So you find any term. I feel like you can do it with any term, probably.
I'll just change one word. You're right, any equation. I could use either equation here.
Yeah. So
Both will give the same answer, or math is broken. They both got to give the same answer.
So if you just do now you do like the 121 one, if you do that.
Yeah. Let me do the fancy math language form. Sub d equals 9 into 1. Mathematicians use this all the time. 1 with a little circle on it. We mean equation 1. And so I get 121 equals a plus 6 times the 9.
Oh, yeah. Then you do that. Then you just minus it.
Yeah. Good.
And then that's the thing.
That's the thingy. 121 minus 54. 67? Is it 67?
Yeah.
So when he said thingy, he meant the A value. His brain moves too fast sometimes to stop and get the terms. What's that? I would, but it better work or something's wrong. So if you go over here and you go 193 minus the 14d, 90 and 36, 126, yep, 67. Yeah? It will work in both of them. It's got to. It's sort of surprising it works, but it has to. It has to be right for both equations. Questions there? I think it says 2 more pages. Is it?
It's just 2 questions.
There's no question.
Oh, I'm just doing more with this now? Yeah? So I found A and D, and it says find the formula. Okay, now that's easy. Once I've got that, Tn equals A plus n minus 1d, but I've got those 2 things now. Incidentally, there probably is a homework question that gives that information and just says find the formula. You're like, well, how am I supposed to find the formula? You've got to do part A first. So that's where my examples are good. You go back and go, what did Mr. Todd do? Oh, he found A and D first. Then I can find the formula. I forget already. Do I remember? A was 67?
D was 9.
And D was 9. And this is right. And if you, oops, That's not right. That's a 9. And if you write that on your test, I'll mark it right. That's good, but that's not, like, it's sort of awkward. Here's the steps to make it less awkward. Bring the 9 out front. That's where we're used to seeing that 9 is out front of the brackets. So you can distribute it in. And then collect up the like terms. Well, it's simplify the formula. I hope I'm not being nitpicky when I say it's not solve the formula. It's like tidy it up. Isn't that nicer looking? I think the answer's in the homework. That's what they'll look like. They'll tidy it all up for you there. Is the spacing on your handout really bad? Yeah, okay. Yeah. It's the first try. I'm working on it. What'd you do on the 27th? Slept in till, who's got the record for sleeping in over the break? We'll see if you beat the calc. 7 p.m. That is the new record. Was that with a normal bedtime, or was that like you were up till?
I went to bed at 8 p.m. and I slept till 7 p.m.
That's impressive. This 50-year-old body doesn't do that. 7 hours is about my maximum, and I got to get up and stretch a little bit or something. Are we okay here? I don't think I did anything crazy there. No? What's the last question? Oh, find the first 3 terms. Now I'm rewinding back to the start of the lesson and showing you what's going on here. Let's go back and find the first 3 terms. Term 1. So what did I find? Tn equals, I forget what I wrote. 9n plus 58. Going to loop back and do the easy part of this lesson. So to get term 1, I go 9 times 1 plus 58, which is 67. We are not surprised by the answer. We already knew that. A was 67. Term 1 is 67. The formula works. Term 2 equals 9 times 2 plus 58. I'll do that in my head. 18 plus 15, 76. I got. And this is how we use the formula to find terms. We just put the number in and sub it in. Term 3, 9 times 3 plus 58, which is 85. And that loops back to, I think, the first couple of homework questions. That'll give you a formula, and you're just supposed to find a few terms by choosing the term number that you want. Oh, I totally get that. I don't have to do any homework tonight. I totally get it. No, friends. I totally get it, so I'm going to do all the homework. So I really get this. So I'm ready for the next lesson, and I'm ready for a potential quiz or test on this.